y. And we want to predict the value of this variable based on the other variable. So we will use the regression analysis. The regression analysis is used to predict the value of one variable based on the other variable. We consider an example. In this example, we want to predict the response variable, the selling price, of houses based on for 5 variables. Where we give that the selling price depend on the size of the house. The larger the house is, the more expensive the house is. Okay. The second variable is the number of bedrooms. Or the other variable, the frontage of the condition of the house, the location measured by the distance from the house to the center of the city. Another example, you want to predict the time content in the extreme in the chemical process. And we suppose that it depends on the temperature, the inner temperature. So the reaction analysis is the technique that involves developing a mathematical equation or the model that describes the relationship between the variable to be forecast and the other related variable. Now we define the regression model. So we suppose that the variable to be forecast is called the dependent variable or the response variable determined by y. While the related variable are called independent variable and determined by x1 into xk, where k is the number of independent variables. The variable to be forecast y depend on k independent variable x1 to xk. So a regression model is given by a mathematical equation that describes the relationship between y and x1 to xk. The equation y equals function f of x1 to xk plus epsilon. In this equation, f is a mathematical function and epsilon is called the other variable. Okay, so chapter 6 is study about the simple linear regression model. Simple linear regression model S, L, R, M. And the simple linear regression and model. First day we saw you to give certain place, go out. Đổi tất cả nói chuyện đọc phải đâu. Tôi nói biết to cái này mà gì đó, nói to hơn. Mà nào nghèo đi vậy. Kiếm thích đóng tiền thì đóng cái này, đúng không? Đừng có cấm đến đâu. Introduction to the simple linear regression model. Okay, firstly we define a regression model. A regression model is called by a mathematical equation. Mathematical equation. Y is f, x1, x2, Okay, so in this equation, we call y equals the response variable or the output variable. The response or the dependent variable. X1, X2, so on, Xk are K picture, or K independent variable. And then epsilon is called the error variable. And f is a mathematical function. If we come back the previous example, the variable y is the selling price, selling price of a house. Variable x1 is the size of the house. Selling price whether in USD, for example, or in million dollars, million numbers, or in USD. The x1 is the size of the house. X2, we can consider X2 is the number of bedroom. X2 is the number of bedroom. X3 is the number of bathroom. X4 is the age of the house. X5 is the distance from the house to the center of the city. Distance, GS measure in years. Of course, size the house measure in meter square. Number of bedroom and number of bathroom, they live in it's a natural number. 1, 2, 3, 4, 5, so on. X5 is the distance from the house to the center of city for them, and measured by kilometers. So we have a relation model. Y is a function f. X1, X2, X3, X4, and X5 plus epsilon. So relation model. If I remember that we can suppose that f is linear, so it's beta naught plus beta 1 x1 plus beta 2 x2, beta 3 x3, beta 4 x4 plus beta 5 x5 plus epsilon. Right? It means that this model is called the multi-linear regression model. Right? The multi-linear regression model. The multi-linear regression model, it means that f is linear. Linear, so f is linear function. There's a linear function. And what multi? Multi means that k equal how many? 5. There are 5 independent variables, greater than 1. And in this model, what are the error variable? Error variable consists of all other factors, all other variables that are not considered in this model. Error variable consists of all other factors or variable that are not considered in the model. Are not considered in the model. It means that the selling price of one house will depend on the other factor outside the value, the selling price. With the same just somehow this with the same size, the same number of bedrooms, the same number of bathrooms, the same age and the same distance to the center, but the selling price of these houses are different, because these houses or the selling price of the houses depend on the other factor, and all the other factor is considered in the error value epsilon. And now in this chapter, we will consider simple linear regression model. We don't study about the multi-linear regression model. For the multi-linear regression model, you will study the cost econometric, the name of the cost. It's not econometric. Okay, so in this chapter we will study about the simple linear regression model. We only consider how many? One input variable, one independent variable, và k equal one. In this chapter. We only consider the model that consider how many? One independent or predictor, predictor variable, and denoted by x. And f is a linear function. And the name of this model is called the simple linear regression model. SLRM. Okay, so now we define what is a simple linear regression model. A simple linear regression model is the following equation. The input or the output variable, the response variable is the y. Depend on how many? Only one variable x. And the linear, the relationship is linear. So the equation beta naught plus beta 1 x plus epsilon plus beta 1 x 1. But there is only one independent variable. So the independent variable x1 denoted by x. Y beta naught plus beta 1. It's equation 1. Okay, so in this model, y is called the response dependent variable. a perimeter of independent variable. Epsilon is called the error variable. And then beta naught is called the intercept coefficient. Beta 1 is called the slope coefficient. That's the definition of SLI or simple linear relation. Equation 1. Now we can consider addition. Example. Why is the price of a house equal beta naught plus beta 1 times x. X is the size of the house plus epsilon. And example, a second example, we consider the relationship between the final exam grade and the midterm exam grade. Variable y is the final grade of student. Y depend on x is the midterm grade. If I did two example, the variable x and y have positive linear relationship because when x increase, when the size of the house increase, because the price of the house increase too. Similarly, if the midterm grade, maybe the final grade, midterm grade increase, the final grade increase too. Làm thì trước khi có tức là bạn ấy đã giỏi rồi thì tự nhiên sẽ giỏi lên, đúng không? Thì anh trước khi 10 thấy thôi là cần học như vậy. Thì đôi khi nó thấp thì sinh viên ít, rồi có giá trị. So in this model, x and y have a positive linear relationship between when x increase, y increase. Okay, here are two examples of a simple linear relation mode. And now we introduce about the data or the sample. For a simple linear relation model, the factor consider an observation. On endpoint. The first point x1, y1, the second point x2, y2, so on, xn, yn. For example, x1 is the size of the first house, y1 is the price of the first house, x2 the size of the second house, y2 is the price of the second house, so on. We observe 100 of this point, and price of 100 house, y 100 is the price of the 100 house. We observe the 10 students. I want the midterm grade of the first student. Y1 is the final grade of the first student, and exam y the midterm and the final grade of the 10 students. So we have n observation or n point. And when you draw the scatter diagram, we split we introduce about the data set. And here is the model, the theoretical model. Y equal beta naught plus beta 1 x plus epsilon. Right? So in this model, in fact, the beta 1 will be positive. Why? Because this chain go on when x decrease, y increase too. So the slope coefficient beta 1 must be positive. Right? Okay, now we add to the fit endpoint or end observation xi, yi, I equal 1 to n to the model. Okay, we have the first equation, we have a system of n equation. The first equation y1 equal beta naught plus beta 1 x1 plus epsilon 1. Right? Y2 equal beta naught plus beta 1 x2 plus epsilon 2. So on yn beta naught plus beta 1 xn plus epsilon n. Right? When you fit the data to the model, we have n equation. Right? Vector x in this equation, we have a value of the error variable. Epsilon 1 is error of the first half, so on. Epsilon n is the value of the error variable of the n observation. And now we introduce the assumption in the simple linear regression model. But we must suppose this following assumption to answer the next question. The assumption. In fact, there are 5 assumptions. 5 assumptions on the simple linear regression model. The first assumption, we suppose that epsilon I and epsilon j are independent. Because the I and j houses are independent. Now when two variables are independent, the covariance between epsilon I and epsilon j equals 0 for both I and j. The second, two errors are independent or uncorrelated. The second assumption, the mean of error equals 0. Mean error, mean of error is 0. The third requirement, the variance of error is constant, sigma squared. Variance of error is constant, sigma squared. The first requirement, the error is normal. Epsilon I follow normal between equal to 0 squared sigma squared. It means the error is normal. And the fifth requirement, the independent variable x and the error variable are independent. It means that the factor in the model and the other factor are independent. This requirement means that the independent variable in the model and The other factor are independent. The other factor are not considered in the model. Are not considered in the model. Are independent. Okay, so this assumption must be supposed to construct the differential statistic, differential decision in the next section. Okay, so now we consider the first question. The first question is the simple linear regression model. We will consider two questions or three questions. Three questions or three problems. In the simple linear regression model, the first problem is the problem of estimation. Estimation the parameter, the model parameter. And the second problem is the problem of hypothesis testing. And the third problem, assessing the model. We will estimate the two parameter model. There are two parameters, the vector beta is the vector beta not beta 1 and the variance sigma square, variance of epsilon. Beta naught and beta 1 is the vector of model regression coefficient. Regression coefficient. Sigma square is the variance of error. And for testing problem, we will test on the slope coefficient. Test on beta 1. And to assess the model, we answer the question how the data fit the model. How well the data can fit the model. Okay, now we consider the first section or the first problem. The problem of estimation in the simple linear regression model. Okay, so we need to estimate two type parameters. Beta is the vector beta naught, beta 1 is the reaction coefficient. And sigma squared is the variance of epsilon. Variance of error. We will need to estimate these two parameters based on the data. The data consists of n point, n observation. x1, y1, xn, yn. Right? Okay, we will use the least square method to estimate these two parameters. We use the least square method. We will use the least square method to find the estimator by estimate beta and sigma Okay, now we introduce the least square method. We decode from when we fit the data to the model. We have y1 is the beta naught plus beta 1 x1 plus epsilon. So we have what epsilon 1 is y1 minus beta naught plus beta 1 x1. Epsilon 2 y2 minus beta naught plus beta 1 x2. So on. Epsilon n yn minus beta naught plus beta 1 xn. Okay? There are n error from an observation. Right? N error of n observation. Okay, now we compute the sum of square of error. Sum of square of error denoted by SSE is epsilon 1 square plus epsilon 2 square plus so on plus epsilon n square. Right? Then equal write the sum of yi minus beta naught minus beta 1 xi square. I range from 1 to n. So what is the idea of this square method? What's the idea of this square method? When you assess a model, but the smaller LSE is, the better the model fits the data. So we want to find estimate the beta naught and beta 1. Even we want to find the model, estimated model, such as the sum of square of error LSE is the smallest, right? But we minimize LSE to find beta naught and beta 1. But the smaller SE is the better the model is. The better the model fit the data. So we find beta naught and beta 1 that minimize SSE. Here's the idea of this square method. We find beta naught and beta 1 that minimize SSE. So how to find the minimum point of this function? How to find the minimum point of function? We solve with equation. We come back to high school or for this function, we come back to a continuous one. How to find what's the minimum point of this function? We solve the equation, the derivative of SE respective to beta naught and the derivative of SE respective to beta 1 equal to 0. So what the derivative of LSE? What the derivative of this function? Respective to beta naught and beta 1. We use the derivative of u square. What the derivative of u square? 2u times u prime. So equal the sum of I for 1 square 2. U is yi minus beta naught minus beta 1 xi, and then what you find? The negative of beta naught respective to beta naught is 1, so minus 1. Multiply with minus 1. Continue. Compute the derivative respective to beta 1. The sum of 2 yi minus beta naught minus beta 1 si 2u. Now you apply, what you apply? Derivative of beta 1 is 1, so minus xi. Equals 0. Okay. So now we solve this system equation. How to solve this system equation? For people at secondary school, secondary school can solve this system equation. 2 times minus 1 is minus 2 is bigger because equal to 0. Take 2 minus times minus 1 equal minus 2 is bigger. Because this equation equal to 0. So it remains the first equation, the sum of yi minus the sum of beta naught. The sum of beta naught is n beta naught minus beta 1 times the sum of xi equal to 0. The first equation. And what second equation? You take xi times yi, and then minus beta naught, the sum of xi, continue, minus beta naught, the sum of xi squared equals 0. Okay? And then from the equation 1, there is equation 1 and equation 2. From the equation 1, you can compute what the beta naught. Beta naught equal 1 over n, the sum of yi minus beta 1 times 1 over n times the sum of xi. You take n beta naught to the right hand side. Then we divide by n. Obtain beta naught is the sum of yi over n minus beta 1 the sum of xi over n. Why the sum of yi over n is y bar minus beta 1 x bar. 1 over n the sum of xi is x bar. And we replace it to the second equation. The second equation becomes the sum of xi yi minus beta naught. So 1 over n, the sum of yi minus beta 1, the sum 1 over n, the sum of xi multiply with the sum of xi minus beta 1, the sum of xi squared equal to 0. So to find beta 1, how to find beta 1? And then you will take to the right side. Beta 1 times the sum of xi squared minus 1 over n the sum of xi whole squared. Okay? It means that beta 1 you multiply with n. The sum of xi by I minus n sum 1 over n is I sum 1 over n is yi is x bar y bar. Okay. Divided by the sum of xi squared minus n sum 1 over n the sum of xi whole square, so n x bar square. And then So, and beta not equal y bar minus beta 1 x bar as a solution. It's clear for you? What is this solution? It's at the secondary school. Okay, now we have break, and we continue to factor compute the point estimate from beta naught